Okay, today is called rational functions, and we've been doing them for a while, but we haven't actually been graphing them. Do you remember this guy? He's the ultimate simple little rational function, and it goes like that. Remember this one? And it's got asymptotes that go like this and this. I'm going to pause for a second as I have a question. So if you had forgotten what this looked like, I contend that there's something I've told you that can graph anything. XY chart. XY chart. Yes, calculators can too, but XY chart. Everybody make an XY chart. I want to remind you how this works. You have to take any number, just any number, like 3.72. Yeah, you can, but that's not a good choice. Choose wisely what kind of x's you want to put in there. A 1 would be a pretty good choice. So you stick a 1 right there in your chart, and when you put the 1 right there in the function, you get y equals what? 1. So 1 comma 1 must be on the graph, and there it is. Now on these graphs, all I require is one key point on each loop, and then the asymptotes. Do you get the idea? I don't need to find exactly all of these little points. I just need one point here on this side and one over here on that side. And usually you can just go over and down and it'll be right there. Okay, but it's safer to check on the chart. So I'm going to put in -1 now. -1 goes in. 1 divided by -1 is -1. -1, -1, yup, it works. Yes? What do you mean by never reach 0? That they get closer and closer to 0 and never touch? Yes, on this, unless you shift it, of course. Now, if I take the whole graph, you know, there's exceptions to everything, of course. But if you shift this whole thing over or up, then it will, if you shift it, I can make it touch 0. See there, it's touching 0.
Yeah, but like if you didn't shift it at all, like the other day you were saying, like if you had it 0.9999, it would
Gotcha. If you can go to infinity, then it will. So if you extend it all the way, but here's the other thing too, and I know this is just a, poking a hole in an argument thing, but there is also, no, I don't want to tell you yet. There's more to the asymptotes, and you'll learn it in due time. For right now, I just say it gets closer and closer and never touches. All right, but there's always more to the story. When you get to the higher level stuff, they say, well, actually, it's kind of like when you first learn square roots. I'm sure you never even knew that there's more than one kind of square root. So technically, the teacher should have been writing a little 2 there each time, because now there's cube roots like this. They never told you there could be a number there, but that answer would be 2, yes. You have learned that. You may have forgotten it, but it's okay. You're going to learn more about those in a different chapter. This is called fraction. It's called rational exponents. So if you get like 27 to the 2/3 power, you'll learn how to do that. It's really not that hard. It's the cube root of 27, and then you square it. What is the cube root of 27? What times what times what makes 27? 3. And then you square it, and that makes 9. So the answer to that's 9. 27 to the 2/3 power is 9. If you really want to make it advanced, you put it to the negative 2/3 power. And it's just 1/9. It's not that hard. All right. Anyway, one thing at a time. Right now, we're sticking in some numbers. We have found a couple of key points. Remember me saying that I just need one from each loop and then the asymptotes. And as long as you just get closer and closer to the asymptotes, you're fine. I don't need these to have a whole bunch of little dots. All right, now, if I get this graphed properly, it helps me answer these other questions over here. The domain, the range, vertical, horizontals. All right, I got a couple dumb little words that might help stick in your head. They really, really do help. Because if I say x equals 2, it's so hard to know, or 3, if that's a vertical or a horizontal. So here's the dumb little words that'll help. They're going to be called the vertical asymptotes and the horizontals. Get what I did there? So the vertical asymptotes are the x equals things. The horizontal asymptotes are the y equals things. Now, where are they right now? Well, they're both at 0, so it's kind of hard to tell them apart. Okay. But vertical, do you get vertical if you talk about somebody's vertical leap? A vertical asymptote is this kind. They run vertically. Okay, so the green one, that's the vertical asymptote. That's this guy. And so that's the one that's at 0. And the other one's also at 0, but it's the horizontal asymptote. Actually, I should have made the other one green. Hold on. I'm going to make this one disappear. I'm going to make it pink because the other word is in green, and that'll make more sense. Now the green one, that's horizontal, like the horizon, and it's green, and it matches up with the green, which makes more sense. I don't have a blue dotted line, otherwise I would have used it. All right. So, what's domain and range? Domain and range are, domain goes this way, and oh, doesn't work, and then it keeps going. What's the one thing that stops our domain? 0. So our domain is from negative infinity to, what stopped it again? 0. Union, 0 to infinity. Very good. Parentheses around everything. Yes? Okay, asymptotes are these dotted lines that the graph won't ever touch. And the reason that they're there is because of this. If I try to stick in 0, do you get it's 1 over 0, and that's a math no-no. You can't do that. Try it with a calculator, 1 divided by 0, and the calculator says error. Can't do it. So you can't have a 0 on the bottom. That's why there's an asymptote there. Okay? So why is there an asymptote at x equals 0? Because if you stick a 0 in the function, it doesn't work. Yes? You have like 35 questions today. I had a thing up there on the net neutrality vote. It hasn't happened yet. We were doing updates last hour on the net neutrality vote. So, all right. Range. The range is everything that y can be. Do you get ranges go this way? And oop, there's something it can't be, and then it keeps going. What's the one thing that the range can't be? Yeah, so you do the same exact thing. It's actually identical to this one, so I'm just going to put an arrow down there. Same exact thing. Is it always the same exact thing? Of course not. In this case, when they're both 0, it'll be the same. All right, let's move on to the next one. Take a look at this. What's different? Do you remember the high-vo thing? Horizontal on the inside, high, vo, vertical on the outside. Okay, if it's on the inside, that's a horizontal thing. Horizontal on inside, vertical on outside. All right, so that's a horizontal move of 1. Do you remember that you can't trust the stuff that's on the inside? And so it's not to the right one like it seems like it should be. This is going to be moved left 1. And how about this part? You can trust that part, and it is telling you to move where? Down 4. So do you get, if I had my original graph look kind of like this, that I could grab it and move it to the left and down, and it would look kind of like that. Now, it's hard to tell exactly if I moved it to the right spot, so it's smart to move it with the asymptotes. So I want to put in my asymptotes. I'll still use pink for this way and green for this way, and they always start there. Whoa, hold on. And then they get moved. So if I move this thing to the left 1, do you get if I grab the pink one? Oh, shoot, hold on. I moved everything. I know, I can lock this. There we go, lock. Okay, if I grab the pink one here and move it to the left, it actually moves to the left. If I grab the green one and try to move it to the left, it actually doesn't even move to the left. You know what I mean? It stays in the same place. So that's obviously not the one that moves it to the left. So when I move to the left, that's this guy. So I'm going to move him 1 to the left, and then the other one moves down 4. down 4. Now I'm going to move the graph to match it. Whoa. Issues. And there. Now, what did I say were those 2 key points? Notice it goes over and down 1, over and up 1. Those spots. Those are the key spots. So you have to have those 2 points and the asymptotes in the right spots, and then your lines just have to get closer and closer to the asymptotes. Okay. So at this point, I feel like I've given you enough that you haven't seen so far a stretch or a flip. But I think you've got enough that you can answer these. If you can remember those dumb little words that I said and stuff, and you can remember how to do the parenthesis deals, would you please figure out the domain and range and vertical and horizontals all by yourself? And then I'm going to ask you to compare it with the kid next to you. See if you get the same exact thing as them. Everything should be the same. If they say Y where they should say X, it's wrong. Okay, just try this one and check with the kid next to you. Okay. Domain, negative infinity. I'm using inf. Why? Because on a Schoology quiz, that's how you'd say it. I would accept it on a test too, INF for infinity. Up until when does it stop working on the domain? The domain goes this way. Stops working right there at -1. Good. If we want to draw this on your, and then erase it would be the best thing, but that's how domain works, goes that way. So it stops at -1, and then it starts working again after -1, all the way to infinity. You can write that, or you can type an INF if you're doing a Schoology quiz. Oh, wait, I don't put a comma in between them. What do I put? A U. Very good. Okay, and then the range is not identical. The range is negative infinity. That part's identical. To range goes this way. And where does it stop working? -4 to infinity. Okay, vertical asymptote. The vertical is the up and down kind. That's the pink one. And that's at -1. And if I forget what it is and I just write that, I will get it marked wrong on the test. Yes, the verticals are the zerticals. X equals -1. And the horizontals are the horizontals. And the horizontal asymptote is that green one, and it's at -4, and it's a y equals -4. Okay, now I want you to see something here, because this will go way faster if you catch this pattern. Do you get that the vertical is the thing that would crash the function? Do you get that the horizontal is how far we moved it up and down? You don't get that? Do you see that this number here is the same as that number there? That's all I'm saying. And then this number here is the same as the thing that crashes that. So if you catch that and you start seeing these, you go, oh, I know the vertical and the horizontal. That's the vertical. That's the horizontal. And remember, verticals are the zertical thing. So that's x equals, what do you think it is? X equals what? 6. And the horizontals are horizontal. So it's y equals -3. Once again, you don't trust that. You do trust that. That's another way to think of it. See how fast you can do the verticals and horizontals? Okay. So y equals, that's a horizontal. Hold on. Y equals -3. And x equals 6. And I've got my vertical and horizontals done. And then, wait a minute. Don't those also tell me the domain and range? Sure they do. Because, do you remember the domain's about x? I'm talking about domain's about x, range is about y. So if a domain's about x, am I going to just put the 6 in here somewhere? Yes, I am, right there and there. It goes from -infinity to 6 and 6 to infinity. And the range? -infinity to, what's the y thing that's important? Right there. -3, and then -3 to infinity. Look at, I didn't even have to make the graph. But there is a test question that we have to graph. So, yes. Does the negative do anything? Absolutely does something. But this, what we're trying to get here, that why did I use a regular 6 and not a -6? It's because you can't trust the things on the inside. Another way to think of it is 6 causes the asymptote because when you stick in a 6, it's when it crashes. Not a -6. Sticking in a -6 doesn't crash it. Sticking in a regular 6 crashes it. The 3? Oh, okay, yes. Yes, this negative absolutely makes a difference, but it's not going to make a difference on my horizontal and vertical asymptotes. All right, so now let's actually graph this thing and see what it looks like. It definitely makes a difference in how it looks. All right, so first off, do you get that these generally would look like this, except this one's got moved? Where? Right? How far? Right 6 and what? Down 3. Right 6. Poop. Hold on. Lock it. Lock it. Right 6. Down 3. Something like that. That's roughly where it is. Except, then this happens. What does that do? It flips it. Now, I know that you know that it's vertical on the outside, but is that going to be an up-down flip or a left-right flip? And you know what? It doesn't matter. Because if you take this one and flip it this way, or you were to flip it this way, it gives you the same result. So it doesn't matter whether it's vertical or horizontal. But if I was asked, I would say that's on the outside, so it's a vertical. And if I was asked, what is a vertical flip over? Verticals go like this, and I would think it through and go, okay, what am I flipping over then? I'm flipping over this thing, which is called the x-axis. So I guess it goes over x. And it's a vertical, so it's a zertical, and you should have known that anyway. All right. Now, last thought. Let's say I think I got it now, and it's this blue graph. Remember, I flipped it. There's quite a few things I could mark wrong on this. First of all, you don't have an exact point here. I think it's actually supposed to be going through that and that. Let me see if I can move those blue lines over to do that. There and there. Next, if I really think that's it, then the XY chart will be happy when I stick that number in. Let's find out if I was right. I went over 4 and down 2. 4 comma negative 2. When I stick 4 in, do I really get negative 2 out? Let's check. Use your brain, stick the numbers in your head, and see if that worked. Did it work? What's 4 minus 6? Negative 2. 1 over negative 2 is negative, and then it's negative of a negative makes it positive a half. Is positive a half minus 3 equal to negative 2? No. Something's messed up. All right, so this is exactly why, and I did this in every class. Pay attention, please. You did something else, I can tell. Stop it. This is why I did this in every class. I made the XY chart and saw, wait a minute, this is wrong, because I want you to do that on the test. The XY chart is really, really important for checking where you made the mistake. Okay, I know something must be messed up. So what do? You go to the XY chart, and you actually stick some points in on the XY chart, and you'll find out what does work. So let's actually make some XY points that actually work, and we'll see what went wrong. You even need to do all the work. Well, here's what you got to do. You got to answer these questions, and you don't have to do them a certain way. You just have to be able to answer them. Okay? So, my first thing is, I'm trying to show you the power of the XY chart for making these right. So, tell me one thing I could stick in easily for X. You don't want to just pick something random like 1. It does not work nice. 3 does not work nice, because I'm going to have 1/3. 6 works kind of nice, but you remember me saying the thing that crashes this is one of the asymptotes, right? So as soon as you... Wait, 6 was a good thing. It's just that it gave us the asymptote. Wait a minute. Let me finish this thought. If x equals 6 is the asymptote, do you get, I just figured out this? Okay. Next, let's put in another thing in the chart. Now, somebody was saying 7. I agree. 7's a good one. because when I stick in 7, this will work nice. That's 1. That makes it -1. And -3 makes what? -4. I guarantee you that 7, -4 is on this graph. 7, 1, 2, 3, 4, 5, 6, 7, -1, 2, 3, 4 is on this graph. I don't know anything else yet. Oh, wait, I did know one thing. The vertical asymptote was at 6. Vertical or up and down lines is at 6. Now, that actually makes some sense, doesn't it? That this would be really close to that line. Okay. Now let's find another point. 5 is a good number. Why? Because 5 minus 6 is -1. 1 divided by -1 is -1. Then I make it negative again, makes it +1. 1 minus 3 is -2. I stuck in a 5, I got a -2. So now I'm going to put a dot there. 1, 2, 3, 4, 5, -2. Ooh, can you see where it's probably going to go now? I can. I know it can't be going like this, because then it wouldn't pass the vertical line test. Okay, so that can't be like that. Can you see it? It must be going like this. But let's get that other asymptote in there. Can you see where the other asymptote must be then? Remember me saying that the other asymptote would be the thing out there? Okay. So y equals, the horizontal asymptote would have y equals -3. So then, what was wrong with our graph that looked like this? Because of the negative, it was flipped. Do you get, instead, it should have looked like that? All right. So I walked you through the other one, and everybody's like, yeah, but we weren't right. How do we check it? How do we find out we weren't right? XY chart. That's going to happen to you on the test. Okay, so let's try one more that's kind of like that. They give you actually this one, I'll just say, if you get that makes a stretch. Here's why. Because there used to be a 1 there, right? And then they times it by 2, and then some kids don't get this, but that 2 goes up on the top because it's really 2 over 1, and that makes the 2 go right up onto the top. And so that is a stretch of 2 when they do that. What helps you find the answers? XY chart. You can make an XY chart, etc. And do you remember me saying the vertical is the zertical, the horizontal, those are Y things? And some kids go, but there's nothing on the outside. How am I supposed to put, what if there's nothing out there? Y equals, there's nothing out there, so it's Y equals 0. And the X equals thing for the asymptote, that's the thing that crashes the function. What crashes this function? 1. Now, would you please find a few points and finish off with the domain and the range? You can already do those based on these guys. And find me some points that actually work and sketch this one. I'm going to pause for a minute while you finish this last example of the graphing kind, where they give you an equation and you graph it. There's one other kind, and that's where they give you the picture, and you have to figure out what the equation is. But those are actually easier, in my opinion. I'll pause for a second while you answer this one. Okay. Check your answers against this. All right. The domain, that was everything except that one number. Why not that number? Why can't I have that in my domain? Because it crashes the function. Okay, some of you guys are talking. I want you to stop now. You'll be working in a moment, and then you'll be able to talk when you're working in your work time, gentlemen. Stop messing around. Okay. Okay, so here's the rest of it. The range is everything except 0. So you should have put a 0 and a 0. Why? Because the y is the range. This is a y thing. Negative infinity to infinity. There. And then the graph. I wish I had a few good points. Well, I could stick in some numbers and find a few good points. If I put a 2 there, that means a 2 is in the x. Then I got a 2 over 1, which is 2. 2 comma 2 must be on my graph. Boink, boink, right there. And then I could put in some other numbers like maybe, give me another good number. -1. -1 works pretty good. I agree. -1 goes in here, and I get 2 over -2, which is -1. So -1 is another spot that this goes through. All right, now let's put in our asymptotes. Our asymptote here at x equals 1, which means there's a dotted line running right down there. And then there's an asymptote at y equals 0, asymptote running right through there. And remember me saying that all I had to have is one dot in each of those loops. And then I can just kind of go pretty much like this and pretty much like that. There you go. Okay, and if the XY chart is agreeing with your graph, then you must be doing it right. That's how you can check yourself. A lot of kids try to skip the XY chart thing. Just think, well, I know where it should be. It should be over here. And then they don't end up getting these points right because they aren't careful with their XY chart. Okay, so what if it's a picture? This one is as easy as it looks. It's moved over, and it starts as 1 over x. It's moved over to the right 5 and up 2. So please tell me, if I said right 5, up 2, you could have done that one, couldn't you? All right. Now, what if my life depended on it and I was like having to prove this to a friend, because if your friend wouldn't probably kill you if you were wrong, but maybe it has to do with your new self-driving cars or whatever. So anyway, this is at 6 comma 3. The question is, if I put in 6 comma 3, 6 and 3, does it work? And the answer is yes, it does. So therefore, I know I did it right. So once again, the XY chart comes in handy. All right, this one, a lot of people are going to think they have it, and they're going to be wrong. Write what you think it is. And I'll pause for a second while you give this one a shot. You always start with 1 over x. Then the question is, do you move it to the right or left or up or down? Looks like right 1, and it looks like up 3. And then you get it wrong. Why? There's a stretch. Very good. And if you think it's a stretch factor of 2, if you're like smart enough to go, oh, something's wrong here, because there should be a dot right here, and there isn't. So they must have done something weird. You can figure it's probably a stretch. Now, if it's all the way over here, do you get that would have been a flip? So it wasn't that. It wasn't a flip, so it must be a stretch. So then that's times by 2 in the front, which climbs up to the top over here. All right, and then I can see if I'm right. Its point right there was 2 comma 5. If 2 comma 5 works on my XY chart, then I'm right. 2, 5. 2, 5. Does it actually work? Yes, it does. So now I know it's right. Okay, a lot of you guys caught this stretch factor of 2 right there. I'm impressed. Okay, this one's harder to see. There's no stretch factor, but what do you think there is? There's a flip, a reflect, a negative in front. Yes. So it's still moved to the left too. And the flip is what's complicated here. And if you want to check to see if you're right, you got to check a point like that spot right there is at -1, -1. You check on your XY chart, you'll find out that -1 actually works in here. And therefore, it must be right. Yep, I double checked it and it's right. Okay, good. And let's start your homework together. It is a Schoology quiz, and I'm going to show you how to type it in correctly. So I'm going to pause while I pull it out. All right, horizontal asymptote. Horizontal is the horizontal. Everybody better start by typing in y equals on that first blank, because you know it has to be y equals something. Now you take a look at it. Where are the y equals things? They're lines that run like this. So y equals what? 0. Y equals 0. Next, the vertical asymptotes. Those are things that run like this. Red and green. Apparently your Christmas involves a little bit of mauve too, or whatever color that is. This is x equals what? 3, good. The domain. The domains, you have to type in this deal. Parenthesis, negative inf, comma. And domains run like this, and it stops working there, and it keeps going. So, that's domain. So, what's the one thing that doesn't seem to work? 3. You could also got that from right here. Union 3 to infinity, except you have to type in INF. Lowercase, all lowercase letters. All the letters are lowercase. No brackets, all parentheses. Somebody told me they used a lowercase u and it worked, but I did look and it looked in the answer key like a capital U, so I don't know what to say. Again, a kid said, I swear I used a lowercase u and it worked. Maybe they both work. I would put in a capital U if I was you, because I looked in there and it looked, I didn't even mean that one, but I would use the capital U in between because, here, I'll show you. I'll reveal the first answer. This is scandalous. Edit, and then it pulls up this, and there's your answers. X equals 0, or Y equals 0, X equals 3, just like we said. And look at that. Doesn't that look like a capital U to you? All right. Oh, you're saying that Schoology is never case sensitive? Oh, it's a checkbox. Interesting. I never knew that, you guys. Thank you for helping me see that. So since the case sensitive box, I knew sometimes it was case sensitive, so I didn't know that. Thank you. All right. So there you go. If you don't get the first one right, that's kind of sad. So from there, if you have issues, remember that the first time you take it, if you do badly, I have it set to give you the answers. And you have it set for unlimited tries. And you have it set for an average score. Why didn't I just take highest score? I was afraid some kids would just take a picture of the answers and go copy them over. And after they fail it the first time, they just get a perfect score the second time. I thought I'd rather see more realistic results, and I will round your answer anyway. So if I get a kid who takes it twice and they get a 7 average, I'm going to give it to them. You know what I mean? Like that, I know that they tried well enough. I'm going to give them full credit. Okay? I don't want kids to just fail it on purpose, copy answers over, and get scores that are better than some other kid who actually did it legit. So that's why I did an average score. All right, so there you have it. You've learned about graphing these guys. Where are we going next? Tomorrow and Monday are going to be new material. Tuesday's a review. Wednesday's your big test. Thursday, one last day before break, we'll do something math related, but it won't be nearly as stressful. And I won't have you leave here with any homework over the Christmas break time or the holiday break time. Cool. That's all I got for you for now.